Chapter 4 is factoring to solve quadratic equations. Okay, and today we're going to use all of the factoring methods that we've learned before in the past. We learned the AC method, we learned the X method, and that's pretty much it, right? We use those two methods to factor. So you can solve some quadratic equations, including equations where b is not equal to 0, by using the zero product property. The zero product property. And the zero product property says that if you are going to multiply, if you have two binomials, you're multiplying them together, or if you have any two numbers multiplying together, if one of them is 0, then the entire thing is going to be equal to 0, because anything times 0 is equal to 0, right? So for any real numbers, it says A and B. If A times B is equal to 0, then that means that A or B has to be equal to 0. Okay? And then here's an example. Here we have x, the quantity x plus 3 times the quantity x plus 2. If those equal, if we multiply this together and then equal to 0, then that means that x plus 3 has to be equal to 0, or x plus 2 has to be equal to 0. Is everybody clear with that? All right. So, problem 1 is using the zero product property to find the solutions. So all we're going to do here, we know that because it says it's equal to 0, that means that either x plus 1 is equal to 0, or x minus 5 is equal to 0. Okay? And then you just solve them for x. So here, we're going to subtract 1 on both sides, so x is equal to negative 1. On this side, we're going to add 5 on both sides, so x is equal to 5. So the two solutions that are going to give you a true statement for this equation are negative 1 or 5. All right, for problem B, if we set both of them equal to 0, 2x plus 3 is equal to 0, and x minus 4 is equal to 0, and we solve for x, so we subtract 3 on both sides, 2x is equal to negative 3, divide by 2, so x is equal to negative 3 halves. That's one solution. The other one, you add 4, and x is equal to 4. And again, those are the two solutions that make the equation true. Simple. How about those? Okay? Same thing. All you're going to do is you're going to solve for solve for the variable. Okay? So there are the solutions for C and D. Very good. And again, like I said, eventually you will be able to do these two-step equations just in your head. Okay? All right, problem 2 is factoring, solving by factoring. You can also use the zero product property to solve equations of the form ax squared plus bx plus c equals 0 if the quadratic expression ax squared plus bx plus c can be factored. Okay? So, in the first problem here, we have no coefficient in front of the first term, right? So that means which method are we going to use? The X method or the AC method? The X method. The X method. Don't forget, we don't want to take 3 days to take a test, right? Yeah. So use the X method, okay? So here, we're going to use the X method. And when we multiply, we want to get negative 14. And when we add, we want to get negative 5. Right? So my factors are going to be 1 times 14, 2 times 7, and that's it. Okay? Now, we want a negative 14, so 1 has to be positive and 1 has to be negative. When we add, we want to get a negative 5, we want a negative, So the bigger number has to be negative. So that means we're going to have a negative 7 and a positive 2. So positive 2, negative 7 are my factors. Then my binomials are m plus 2 times m minus 7 equals 0. And now you set each binomial equal to 0. M plus 2 is equal to 0, and m minus 7 is equal to 0. So the two solutions to this equation are m is equal to negative 2 and m is equal to positive 7. Very good. For letter B, again, the coefficient is 1, so we're going to use the x method. So when we do the x method, when we multiply, we want a negative 20. When we add, we want a positive 1. The factors for 20 are 1 times 20, 2 times 10, 4 times 5. Right? When we multiply, we want a negative. So that means one factor has to be positive and one has to be negative. Now because we want to get a positive when we add, the bigger one has to be positive. Very good. So we're going to have a positive 5 and a negative 4. Positive 5 and a negative 4. So we've got p plus 5 times p minus 4. That's equal to 0. So p plus 5 is equal to 0, or p minus 4 is equal to 0. So p is equal to negative 5, and or p is equal to positive 4. And those are your solutions. So for letter C, problem C, we are going to use the AC method because we have a variable in front. We have a coefficient in front of the first term. So when we multiply 2 times 18, let me write AC. That's going to give us 36, right? So our factors of 36, 1 times 36, 2 times 18, of course, 3 times 12, 4 times 9, and 6 times 6, right? All right. Now, we want to get a negative 15. So those are the factors that we're going to use, okay? So we put those back into our equation. So we've got 2a squared minus 3a minus 12a plus 18 is equal to 0. And now we'll group. So when we group, we're going to go ahead and group those two and those two. So what can I take out of the first binomial? Just a. Very good. So a comes out, and what's left is 2a minus 3. And what can I factor out of the second one? 6. And we want to take out a negative 6 because we want this to be positive, right? So we want to take out a negative 6. So we're going to end up with a positive 2a minus 3. Very good. And that's going to be equal to 0. So my two binomials then are the two like binomials, 2a minus 3. And the second one is a minus 6 equals 0. You got that? Okay. So now we can set, using the zero product property, we can set them each equal to 0. So 2a minus 3 is equal to 0, and a minus 6 is equal to 0. So adding 3 on both sides, 2a is equal to 3. Dividing by 2 on both sides, So A is equal to 3/2. And on the other side, A is equal to positive 6. All right, with problem 3, it says writing in standard form first. Before solving a quadratic equation, you may need to add or subtract terms from each side in order to write the equation in standard form. Then you can factor the quadratic expression. Okay? So on this side, we want to make sure that it's going to be equal 0. Okay? So for this, to make this equal 0, we're going to add 49 on both sides. Okay? So we've got x squared plus 14x plus 49 is equal to 0. Okay? So let me just test you real quick. So we're going to do 7 times 7. So we've got an x here and an x here, and we have 7 times 7. Now, when we add, we want to get a positive 14. When we multiply, we want to get a positive 49. So they either, when we multiply to get a positive, they either have to be both positive or both negative, right? But when we add, we want to get positive. So, what are my two factors going to be here? Positive 7 and positive 7. Is everybody clear? Very good. So we just did the x method in our head. So, x plus 7, and do I have to do this twice? No. So x is equal to negative 7. All right, problem 4 is using factoring to solve a real-world problem. You're constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around, and the total area of the frame and the photo to be 391 inches squared. What should the outer dimensions of the frame be? Okay, so area is what? Of a rectangle is length times width. And here, our area is what? 391. Very good. So, the length times the width has to be equal to 391. Okay? So looking at this picture, we've got the length here, and we've got the width there. So the length then here is going to be 2x plus 17. What is our width going to be? 11 plus x plus x, that's 2x. So this is going to be 2x plus 11, right? So when we multiply this out, we're going to have the 2x plus 17 times the 2x plus 11, and that's going to be equal to 391. So I'm going to go ahead and FOIL this, okay, because we need this to be in standard form, okay? So let's FOIL. So 2x times 2x is 4x squared. Outer, 2x times 11 is
22x.
very good. Inner, we've got 17 times 2x is 34x. Very good. And last, 17 times 11 is 187. Very good. Is equal to 391. So now we can put our like terms together. So when we put our like terms together, we end up with 4x squared plus 56. Whoops.
Did you just mess up on recording?
56x plus 187 is equal to 391. All right, so now, can I factor this yet?
No, you
Not yet,
391.
because it has to be equal to
0.
0. Very good.
0.
So now we're going to subtract 391 on both sides. So we end up with 4x squared plus 56x minus 204 is equal to 0. When I factor this, the first thing I want to see is, can I take anything out of here to make my numbers a little smaller? I can divide by 4. Very good. So I'm going to factor out a 4, and I'll end up with x squared plus 14x minus 51 is equal to 0. And so now, because the coefficient in front of the first term is 1, we're going to use our x method. Very good. Our x method, actually I'm going to do our x method over here. When we multiply, we want to get a negative 51, and when we add, we want to get a positive 14. Okay? So the factors of 51 are 1 times 51 and 3 times 17. Anything else? No? No? So which one of those do you think we're going to use? The 3 times 17, right? Okay, now because we want to have a negative 51, then 1 has to be positive, 1 has to be negative. Which one has to be which if we want to get a positive 14?
The smaller one. The smaller one is negative.
Very good. The smaller one is negative, and the bigger one is positive. Very good. So we have a negative 3 and a positive 17. So we've got 4 times, what is this, x minus 3 times x plus 17 is equal to 0. And now we set each term equal to 0, right? So 4, if I say 4 is equal to 0, that's not a true statement, right? So that just stays the same. Okay, that just stays there. Stays 4. So now we have x minus 3 is equal to 0, and x plus 17 is equal to 0. So x can be equal to 3 what? 3 inches, right? Or x can be equal to negative 17 inches. Which one of these does not make sense? Very good. Why does that not make sense? Because you cannot have negative inches. Is everybody clear? All right. Now, also, I wanted to point out here, because we have 3 terms here, I want to point out, if this said 4x, okay, then we would have a 4x equals 0, right? Or a 4x plus 3 or something, okay? You would set each term equal to 0 and then solve for your x. Is everybody clear?
Yeah.
All right, and that's it.